It began without a declaration. On the night of June 15, 1944, radar operators on Kyushu saw a single trace rise beyond known altitude. They recalibrated their screens, then watched the mark climb past 30,000 feet and keep climbing. Guns waited for orders that never came. Moments later, entire wards went dark as power grids shut down. In the silence, civilians stepped outside. The sky held a pale glint that drifted soundlessly across the moon. Searchlights swept, found nothing, and turned away. The object moved faster and higher than any aircraft Japan had built or captured. Minutes later, the hum faded east. No explosions followed. Only the blackout remained. At regional command posts, technicians confirmed the figures. Speed, altitude, and range exceeded every defense table. Japan's protective distance had vanished. Across the islands, new orders spread. Lights out, cities dark, radio silence after dusk. The intruder was not a phantom. It was a machine from another scale of war. The Boeing B-29 Superfortress, America's secret weapon designed to reach any point on Earth. In that single night, Japan crossed from belief to realization. The homeland had witnessed the future of war, and it arrived in silence. It began as an equation written in metal. In 1940, the United States Army Air Forces defined a requirement no aircraft had ever met: a bomber able to cross an ocean, carry 10 tons of bombs, and return without refueling. Boeing accepted the problem. Their answer was Model 345, the prototype of what would become the B-29 Superfortress. Designing it meant rewriting the limits of flight. The Wright R3350 engines promised record power but ran near combustion. Pistons seized, exhausts ignited, and fire consumed prototypes. Test pilots died with their notebooks in hand. Each failure was logged, analyzed, and replaced by a marginal improvement. The process was industrial evolution measured in lives. By mid-1942, production contracts were signed before final tests were complete. Boeing led the program from Wichita and Renton, while Bell Aircraft built airframes in Georgia and Martin in Nebraska. Subcontractors numbered in the thousands. A nationwide grid of suppliers manufactured everything from hydraulic pumps to oxygen valves. Drawings were microfilmed, flown across the country, and updated weekly by telegraph. It was not a factory chain, it was a living network. Inside the plants, shifts ran 24 hours. Women drilled rivets into aluminum skins while inspectors checked pressure seals with soap bubbles. Machinists calibrated analog fire control computers capable of tracking enemy fighters automatically. The cockpit was pressurized, its compartments linked by a narrow tunnel through the bomb bay. Crews would later crawl through that tube in flight, breathing air conditioned by compressors once used in submarines. Accidents were routine, engines overheated, landing gear collapsed, entire test aircraft burned before clearing the runway. Yet schedules advanced without pause. The logic was clear: problems could be solved faster in quantity than in isolation. Each month's production became the next month's test fleet. The B-29 structure embodied American manufacturing. 2 million individual parts, 60,000 assemblies, and 250,000 rivets, joined with tolerances measured in thousandths of an inch. Quality control inspectors stamped every section before shipment. Rail cars carried wings, fuselages, and turrets between states like arteries of a mechanical body. Costs rose beyond prediction. Each bomber consumed enough aluminum for 5 fighters and required crews trained in engineering as much as combat. But the United States could afford both the material and the time. War had turned industry into its own form of weapon. By late 1943, the first production B-29s were flight-ready. Crews began training under the newly formed Tinsuoan Bomber Command. They learned navigation above cloud, coordination by radio, and maintenance of systems more complex than anything in service. Each aircraft represented 200 men on the ground, logisticians, welders, and mechanics who kept the chain unbroken. Performance reports verified what the design promised: maximum speed, 360 miles per hour, service ceiling, over 30,000 feet, range, 5,000 miles. Payload, 10 tons. No other bomber matched the combination. At that altitude, Japan's interceptors and guns would be useless. To make those statistics operational, The United States built a second project, logistics. Bases were prepared in India and China for Operation Matterhorn, the first attempt to reach Japan directly. Bulldozers carved airfields through jungle and mountain. Fuel, bombs, and spare parts were flown over the Himalaya in missions that cost more lives than the raids themselves. The early sorties proved the concept. B-29s carried bombs higher, faster, and farther than any aircraft before them. Even when results were minor, the shock was strategic. Japan, once unreachable, was now visible on a navigator's chart. At home, the scale of production expanded further. Boeing's Wichita plant became a city of metal, 2 million square feet under one roof. Every hour, engines started for ground tests that shook the windows of nearby houses. Each completed bomber rolled out with the same ritual, flags raised, signatures on the nose, crews ready to depart for the Pacific. The nation's labor force followed a single tempo. Day and night merged into the rhythm of assembly. Factories did not celebrate launches. They counted them. Engineers tracked component output as if it were artillery fire. Every unit delivered meant one more target within range. When the first full squadron assembled in India in early 1944, the concept had become reality. Ground crews aligned rows of silver aircraft across the field, their wings reflecting the sun. The men who had built and tested them now prepared to use them. The training schedules, the production quotas, the engineering tables, all led to this point. Each B-29 standing on that runway represented the mathematics of industrial war. Every rivet carried calculation. Every gallon of fuel equaled a fraction of distance. The Superfortress was no longer a weapon among many. It was the physical proof that logistics had become strategy, and that the arithmetic of production could now decide the fate of nations. The engineers had finished their equation. The next variable would be fire. The first wave rose from India in June 1944. Engines strained against heat as the bombers lifted heavy from the dirt strip. Their route ran north across the Himalaya, then east toward fields in China. There they refueled, rearmed, and waited for the weather to clear. The mission name was Matterhorn, a logistical bridge made of fuel and risk. Every gallon counted. To deliver 1 ton of bombs to Japan, 12 tons of fuel were burned, hauling fuel to the forward bases. Cargo planes climbed into monsoon winds loaded with gasoline, returning empty or not at all. Pilots called it the most expensive supply line ever flown. The arithmetic was absurd, but it placed Japan within reach. On June 15th, the objective was Yawata. Its steel mill powered half the Kyushu industry. The bombers climbed to 30,000 feet, their engines near failure, and crossed the coastline in darkness. Clouds masked the city. Bombs fell wide. Only one struck the target. But the proof was enough. Japan was no longer untouchable. Sirens sounded across Kyushu. Civilians ran to shelters, staring at the empty sky as flashes appeared beyond the horizon. Anti-aircraft guns fired blindly into clouds. Searchlights traced white arcs across the dark, never touching the bombers. When the explosions stopped, only silence remained. The first American bombs had reached the home islands. Operation Matterhorn continued. Raids against Nagasaki and Sasebo followed. Engines overheated, fuel tanks ruptured, and bombers landed crippled in muddy Chinese fields. Mechanics worked by lantern light, replacing pistons and patching bullet holes with scavenged aluminum. Each repaired aircraft returned to the line. The system consumed men, machines, and patience, but it kept moving. The flight path over the Himalaya became legend. Crews called it the hump. They faced downdrafts, ice storms, and oxygen starvation. Some aircraft vanished into cloud and were never found. Others returned with wings coated in ice, instruments frozen, and engines sputtering. For every bomber that reached Japan, another was lost to the mountains. Yet each mission refined the process. Precision was elusive. The high jet stream over Japan scattered bomb patterns by miles. Norden bomb sites could not correct for the shifting wind. Reconnaissance photos showed isolated craters scattered across farmland and rivers. Targets remained standing. Hansel's staff adjusted release tables, but accuracy stayed mathematical, perfect in theory, useless in practice. In Washington, Henry Arnold saw more value in repetition than accuracy. Each mission tested procedures, fuel logistics, and endurance. Crews gained experience navigating across featureless darkness. Maintenance crews learned how far engines could run before fire. Every flight was data for the next. Then the ground changed. In July, Marines took Saipan. In August, they seized Tinian and Guam. Airfields rose from coral within weeks, leveled by bulldozers working 24 hours. The war's geography collapsed. From the Marianas, the distance to Tokyo was half what it had been from China. The bombers could now carry heavier loads and return with fuel to spare. Construction on Tinian became the largest airfield project in history. Seabees paved runways long enough for 5 aircraft to take off simultaneously. Hard stands covered hundreds of acres. Fuel tanks, bomb dumps, and repair hangars formed a grid visible from orbit. It was the industrial mirror of the cities the bombers would soon erase. The first B-29 groups transferred from India to the Marianas in the autumn. They landed between scaffolds and cranes, taxiing past crews still laying steel matting. Ground personnel unpacked crates marked property of U.S. Army Air Forces. Within weeks, the base functioned like a production line. Planes rolled in for refuel, rearm, and repair with the same precision as factory ships back home. From these islands, new operations began. Formations took off before dawn, climbed through humid air, and set course for the Japanese mainland. At altitude, the Pacific stretched featureless in every direction. The men navigated by stars and dead reckoning. Each hour of flight carried them farther from radio range, closer to the unseen coast. Japan felt their presence before it saw them. Radar stations tracked massive signals approaching in waves. Cities dimmed their lights. Train stations shuttered. Blackout curtains hung across factory windows. For the first time, the population understood that the Empire's sky no longer belonged to them. The results remained inconsistent. At 30,000 feet, wind shear tossed the formations apart. Bombs fell wide again. LeMay's maps filled with empty circles around missed targets. Yet each mission stretched the boundaries of endurance. Crews spent 14 hours in freezing air, surviving on oxygen and discipline. Every successful return was a victory of logistics over weather. Engines continued to fail. The Wright R3350's heat problem persisted. Mechanics learned to replace cylinders in 12 hours, working barehanded over glowing metal. Oil fires were common, spare parts scarcer. But the fleet expanded and experience hardened the crews. What had started as experiment now became routine. By December, the Marianas had turned into the world's largest bomber complex. Rows of silver aircraft stood wingtip to wingtip, stretching from runway to horizon. Supply ships delivered crates of bombs daily. New arrivals were painted, numbered, and folded into squadrons. Every island operated as a component in a single machine: production, deployment, execution, return. Japan adapted with equal speed. Air defense networks expanded, radar coverage increased, and night fighter squadrons patrolled coastal zones. But the enemy's altitude and range nullified defense. The blackout grew permanent. Residents timed their evenings by sirens. Children slept in shelters. Fire brigades trained each night under artificial alarms. The war had entered a mechanical rhythm: launch, strike, return, repair. Each mission was a test, each result a refinement. Across the Pacific, the process continued without emotion or pause. The system was learning, and its learning curve pointed directly at Tokyo. By year's end, Japan had turned gray under nightly alerts. The factories still worked, but morale eroded. Officers demanded results from exhausted crews who could no longer see their targets. Every new raid felt heavier, more deliberate. The avalanche was building, and its weight had not yet reached its peak. On Tinian, a new commander studied the reports and found the flaw. Altitude was safety for the bomber, but salvation for the target. He looked at the figures: wind, accuracy, survival, and drew a single conclusion: victory would not come from above the clouds. The next phase would descend to Earth. By autumn, maps and results refused to agree. High-altitude theory met wind and cloud. Bomb patterns slid, factories endured, and the calendar moved faster than the damage charts. Reports stacked neatly, but the columns for effect lagged behind the columns for effort. General Haywood Hansell trusted precision. Crews trained for daylight, tight boxes, and bomb sites held steady. Over Japan, the jet stream wrote different rules. Release points drifted by miles. Reconnaissance showed craters in water meadows and parks. Doctrine remained clean. Impact did not. Photo interpreters filled boards with target prints and grease pencil notes. Circles marked intended aim points. Arrows traced the actual fall. The captions grew longer and the results stayed thin. The problem was no longer courage or discipline. It was altitude and wind. The Marianas expanded into a grid of steel and fuel. Isley Field on Saipan, North Field on Tinian, and the bases on Guam gained letters for taxiways and numbers for hard stands. Control towers counted miles of aluminum. Before dawn, rows of bombers rolled nose to tail under tropical haze. On the other side, civil defense hardened routine. Ward captains checked buckets, axes, and ladders. Fire breaks were cut through close-packed wards. School children drilled under blackout curtains. Wooden houses stood roof to roof across canals and lanes. Everyone understood what sparks would mean. In Washington, the patience for theory thinned. General Curtis LeMay arrived to command the force. He read the summaries, listened to crews, and walked the lines in heat and dusk. Engines and wind were constants, tactics were not. He would change the parts that moved. Procedures shifted first. Formations tightened only when needed. Routes bent to avoid the steepest climbs. Altitude bands varied to step around the worst wind layers. Briefings opened with fuel arithmetic and closed with payload fractions. The crew focus moved from elegance to throughput. Then came weight. Defensive turrets were pulled, ammunition cut, and armor plates set aside. The risk was clear on every face, but the numbers ruled. Each missing gun became fuel or fire. Range climbed. Payload climbed. Survivability would be measured at the target, not in duels at height. Night turned from refuge to tool. Airborne radar guided long overwater runs and painted city outlines through haze. Pathfinders marked the first corner. Streams of singles followed by time, not by boxes. Geometry changed from symmetrical walls to a river of aircraft. Ordnance crews rolled out pallets of incendiary clusters. Each cluster hid dozens of bomblets filled with jellied gasoline. Tests in desert ranges had burned wooden blocks built to the pattern of Japanese wards. The photographs were conclusive. If ignition began fast enough and wide enough, fire breaks could not hold. Weather officers brought layered wind tables by hour. LeMay stopped fighting the jet stream. He planned beneath it. Chosen altitudes were low, where drift was small and aiming was direct. The new risk was flak and night fighters. The new advantage was straight fall. Fire planning shifted from points to patterns. The opening wave used high explosive to break mains and lift roofs. Incendiary clusters followed to seed hundreds of small fires. Heavier cans finished the sequence to hold heat. The objective was not a mill or a dock. It was a rectangle of streets. Ground routines bent to feed the change. Gun tracks stayed empty. Armor racks gathered dust. Fuel loads were recalculated around shorter climbs and quicker exits. Turnaround targets were posted like factory quotas. The bomber changed nature. It was less fortress and more carrier of fire. Japanese fighters still rose, but the night narrowed their window. Searchlights chased single engines. The stream slid along coasts at set minutes, then turned inland at right angles. Timing replaced massed formation as protection. Crews called ranges in flat voices and stayed on schedule. Trials began against industrial wards beyond the capital. Night photos showed long bands of light where lanes burned end to end. Fire brigades fought wind, heat, and falling embers. Reports recorded hose failures when pressure died and pump houses lost power. Ignition outran response. Damage assessments at last matched intent. Analysts traced continuous burn fields, not scattered craters. Blocks counted as lost rather than dotted. Crews returned with soot in seams and the smell of smoke in clothing. Debriefs grew shorter. The pattern worked. The question became scale. Takeoff shifted toward late afternoon to arrive over target by night. Maintenance windows moved to mornings. Briefings stressed the exact spacing between singles, radio silence until coast in, and drift angles at low height. Navigation lectures taught straight lines by clock and speed across black water. Mining joined fire. Bombers dropped naval mines into harbors by radar line. Channels closed. Convoys waited for sweeping that never caught up. Railheads filled with cargo that could not move by sea. Cities began to lose coal and rice before they lost roofs. Pressure widened without new raids. In Tokyo, staff papers moved from optimism to contingency. Machine tools were dispersed to schools, shrines, and sheds. Some families left for rural prefectures. Many stayed by work and water. Shelter charts multiplied. The city knew a test was coming and could not change its nature. On the islands, pathfinders practiced marking corners through ash and glare. Crews memorized grid squares by letter, not by landmark. The aim was coverage that grew from one lit point to a sheet. The first minute mattered more than the 15th. Start fast, and the fire would carry itself. The diagrams for the capital were large and simple. The wards were dense wood and paper tied by canals. If several ignition lines started together, the firebreak plan could not keep pace. The brief stated the target plainly. Do not chase a factory. Fill the rectangles until the map turns black. The final board before the major shift held a few lines. Altitude in single digits by thousands. Airspeed fixed. Fuel trimmed to the hour with narrow margin. Guns removed except the tail. Bomb sequence in chalk. Crews signed their aircraft and walked into warm wind and noise. At dusk, propellers blurred along the rows. Navigation lights stayed dark. The stream lifted one by one, turned on course, and settled into slots by time and distance. Over the ocean, the scope showed faint coastlines ahead. Every cabin was quiet except for checklists and the slow count of minutes. In Japan, wardens watched the horizon, then the clocks. Sirens started their long rising call. Streets emptied, stations dimmed, water points filled with buckets that would soon boil dry. The city exhaled and waited. Engines approached as a low, steady pressure on windows and doors. The new chapter would begin with ignition, not impact. It would test a nation built of wood and paper against a method built of fuel and timing. The stream crossed the bay and aligned with the first corner. The change LeMay had drawn on a board now moved in the dark above the roofs. Tokyo's final winter night began with still air and clear stars. The date was March 9, 1945. Weather officers at Tinian reported low wind and perfect visibility. On the island, 325 bombers stood in line, engines warm, loaded with M69 incendiary clusters filled with jellied gasoline. There were no precision targets on the maps, only rectangles marked by wards. At dusk, the first wave lifted from the coral runways, each aircraft leaving a glowing trail of exhaust across the Pacific. Crews flew low to conserve fuel, arriving over Tokyo just after midnight. From the ground came the first long wail of sirens. Fire brigades moved to assigned posts. Then the pathfinders appeared and dropped their signal markers, green and white flares that drifted through clear air. The bombardiers aligned their sights. The first cluster opened above Shitamachi. Hundreds of bomblets scattered and burst, punching through wooden roofs and exploding in narrow streets. Within minutes, individual fires merged. The wind drew air into the core, feeding a rising wall of flame. Oxygen collapsed. The city became a furnace. Communication broke down as telephone lines melted. Pumps lost pressure. Fire trucks jammed in intersections filled with refugees. Water boiled in hoses. Streets vanished in brightness. Pilots at 5,000 feet felt heat pushing their bombers upward. Crews spoke in short lines. Turbulence, rising heat, no visibility. From above, Tokyo was a moving sea of light. By 3 a.m., the firestorm consumed entire districts. 279 aircraft completed their runs, dropping nearly 2,000 tons of incendiaries. The glow reached the horizon. Navigators on later waves could see it 200 miles away. When the last formation turned for home, the wind carried burning debris far out over Tokyo Bay. At dawn, reconnaissance aircraft photographed 41 square kilometers of destruction. The city center was gone. 90,000 people were dead. 1 million were homeless. Tokyo's industry, rail hubs, and housing had ceased to exist. Yet the bombers were already being refueled for the next night. In the following 10 days, Nagoya, Osaka, and Kobe followed the same sequence. Each night opened with flares, expanded into fire, and ended in ash. 40 square kilometers per city became a new operational metric. Factories, shipyards, and urban grids vanished in the same pattern. Firestorms erased maps faster than they could be redrawn. By April, 60 cities had been hit. In each, the outcome was identical: silence before, wind during, emptiness after. Anti-aircraft fire dwindled, ammunition depots were gone, fighters failed to intercept. The air defense network remained on paper. Japan's war production fell by half in 2 months. For the first time in history, war had become mechanical at every level. Fuel, altitude, and temperature determined victory. Crews flew 14-hour missions through darkness and smoke, returning to base as data points. LeMay's reports measured tonnage, area burned, and percentage destroyed. The results were mathematical, detached, and final. Civilians adapted to fire. Families dug shelters under gardens. Students filled sandbags. Cities rehearsed evacuation drills by day and executed them by night. It changed nothing. Each raid produced the same pattern: ignition, wind, collapse. The difference between survival and death was geography. LeMay expanded the method to every industrial center still marked on his maps. From April to July, the campaign turned into a schedule. Aircraft took off every night, each operation planned like a shift in production. By summer, 95,000 tons of incendiaries had fallen on Japan's cities. Smoke plumes climbed 5 miles into the atmosphere. Factories dispersed into rural barns. Tools were carried by hand to small workshops hidden in fields. Even there, bombers reached them. Secondary raids hit rail junctions, power stations, and fuel storage. The destruction moved inland, following the same cold arithmetic: distance, payload, fuel, return. By June, Osaka's industrial quarter burned to the foundations. Yokohama disappeared in a single night. Toyama lost 99% of its structures. The campaign had no pause. Each mission ended with the next one already fueled. The empire's map turned gray. In Tokyo, the government issued new orders for dispersal and defense. None could be met. Roads were blocked by rubble, water systems were ruined, fire brigades lost their engines to fuel shortage. People moved by foot across cities that no longer existed. American analysts measured the outcome from photographs. They no longer saw cities, only outlines. Entire prefectures glowed white on infrared film. By midsummer, Japan's industrial output was 70% below the previous year. The raids had done what invasion could not, end the country's ability to fight. Still, the campaign continued. Each bomber carried fuel for one more run. Each target became a test of endurance. By July, there were no primary cities left. The superfortresses dropped mines into harbors, cutting shipping lanes. Coal stopped moving. Power plants went dark. Trains froze on tracks. At Tinian, a new group of modified B-29s prepared under armed guard. Their payloads were sealed cylinders known only to a few officers. The program ran under the codename Silverplate. The aircraft were lighter, faster, and flown by select crews. Their targets were not chosen for size, but for symbolism. On August 6, 1945, one of them lifted from Northfield, Enola Gay. 6 hours later, it released a single bomb over Hiroshima. The explosion erased 4 square miles of the city in seconds. 3 days later, Boxcar followed to Nagasaki. The war's final evolution had begun. In Japan, the scale of destruction ended all illusion. Entire cities vanished without fire. Command posts ceased transmitting. Civil defense no longer assembled. The empire entered silence. For the men who flew the B-29s, the end came without ceremony. LeMay's daily reports reduced victory to figures: cities burned, bombs expended, sorties flown. To them, the pattern had completed itself. On August 15th, Emperor Hirohito spoke by radio for the first time. His words were faint through static. Japan would surrender. The broadcast reached homes that had no walls and streets with no names. In the Marianas, engines cooled for the last time. The avalanche had ended. The system built to burn a nation had run its course. The sky over Japan grew empty again. The B-29SS stood parked in rows, their wings streaked with ash and salt. The war that began with a silent light above Kyushu had ended in light far brighter. Japan was not defeated by armies or invasion. It was dismantled by numbers, altitude, tonnage, and the industrial repetition of fire. When the fires stopped, Japan faced a silence deeper than defeat. From the air, its cities appeared as gray stains where streets once met. Rail lines crossed fields of ash. Rivers shimmered with debris. The electrical grid was gone. Lamps stayed dark. For the first time in centuries, the archipelago slept without light. Between March and August 1945, 67 cities had been struck. 40% of Japan's urban area lay destroyed. Nearly 9 million people were homeless. What remained of industry operated in fragments, machine tools in schools, lathes in barns, furnaces in caves. But transport had collapsed. Coal sat in mines, rice in fields. Trains could not move, ships could not dock, factories could not assemble. The empire that once stretched across the Pacific could no longer feed itself. At night, the blackout continued. The order that once hid cities from bombers now hid emptiness from sight. Candles replaced bulbs. Generators sputtered for a few hours each evening, then fell silent. Radio stations broadcast short bulletins until fuel ran out. Across the islands, silence replaced motion. The darkness that had begun as defense became the nation's condition. In Tokyo, survey teams moved through the ruins with clipboards and cameras. Engineers recorded dimensions of destruction. Square meters burned, steel melted, timber consumed. They found uniformity. Streets were reduced to white ash and twisted rebar. Wooden homes had vaporized. Entire industrial districts had become fields of carbon dust. The data read like design, destruction by pattern, not accident. On the airfields of the Marianas, the bombers stood quiet. Their wings sagged under tropical heat. Mechanics drained the last fuel and oiled engines for storage. Hundreds were scrapped before they reached 100 flight hours. Others were scavenged for parts to support relief operations. The same crews that once loaded incendiaries now packed food and medical supplies for Japan's starving cities. In Washington, reports credited the B-29 program as the most expensive single-weapon system of the war. $3 billion, 4 assembly lines, and nearly 4,000 aircraft, a campaign of engineering larger than any fleet in history. Its success had not been measured in battles won, but in time saved. Industrial power had become a substitute for invasion. The Superfortress left behind a new idea of distance. It had flown above weather, above defense, and above geography. It proved that no frontier could shield a nation from organized production. From that moment, air power ceased to be support. It became the war itself. As the occupation began, American engineers inspected what remained of Japan's aircraft industry. They found incomplete jet fighters, underground factories, and design offices turned to rubble. The contrast was total. Where Japan had relied on spirit and improvisation, the United States had relied on measurement. The outcome had been decided before the first sortie left the ground. Reconstruction started in late 1945. Rubble was cleared by hand. Rail lines reopened in fragments. Concrete replaced wood. Within a year, Tokyo's grid began to reappear, straighter, wider, fireproof. Yet under every new foundation lay the memory of that night in March, when modern war had descended from the sky. The B-29's influence continued. Its airframe evolved into the B-50 and the first long-range reconnaissance platforms. It carried atomic weapons through the early Cold War and surveyed weather across the globe. What began as a bomber became the prototype for global reach, a flying statement that industry could now shape history. For those who flew it, the memories never faded. They remembered the sound of engines over the Pacific, the glow of cities seen from 20,000 feet, and the silence that followed. Many would say the war had reached its logical limit. Others saw only the beginning, a future ruled by machines, numbers, and precision. In the darkness of surrender, Japan began to rebuild using the same logic that had destroyed it: efficiency, coordination, and scale. The empire that had fallen to production rose again through it. The war had ended, but the equation remained. The B-29 had proven that technology could erase distance, and that no nation could ever again claim safety through isolation. By the end of 1945, Japan's nights were still dark. Cities rebuilt in grids of concrete and steel, but light returned slowly. Windows stayed shuttered long after curfews ended. The blackout had become habit, a memory of engines in the sky. Across the Pacific, the factories that once produced bombers shut down in silence. Assembly lines stopped, workers went home, and the sound of riveting ceased. The B-29 had finished its purpose, but the system that built it, total coordination of science, labor, and logistics, became the foundation of a new world. Historians would call it strategic bombing. Engineers called it process. The figures remained exact. 67 cities destroyed, 300,000 tons of bombs dropped, millions displaced. The precision was the message. Destruction had become measurable, repeatable, industrial. In its cold efficiency, the B-29 defined a new kind of power. It proved that distance no longer protected. That scale could decide war without battle. When the engine stopped, a different truth emerged. Humanity had built machines that could reach anywhere and left behind cities that could never forget.